Hello and welcome to Unacademy. Welcome to another session in our NCERT Fundamentals series, where today we take up a very important topic relevant for the prelims as well as the mains examination, that is the topic of tropical cyclones. Now today we shall be dissecting this aspect of tropical cyclone, try to understand what this cyclonic circulation is about, the necessary conditions which lead to the formation and creation of the tropical cyclones, and why is it that tropical cyclones end up causing floods in the coastal areas. So these are the important nuances that we are going to have a discussion for. But before that, a very important announcement. Now most of you, as you are preparing, you are having a well-versed idea about the subject knowledge. But then a suitable and significantly capable bureaucrat also needs to have an idea about the practical implementation and the practical difficulties faced in the field. So in order to get rid of that issue and in order to provide you a broader perspective and a broader level of exposure, we at Unacademy, where you get an opportunity to interact basically and listen to various different eminent personalities from the sphere of politics to the aspect of eminent personalities, and you get to learn from them significantly and get an idea about the issues on the field. So do attend this summit and you can register for the summit for free. The link is provided in the description below. Having said that, now let us take a look at the topic for discussion. So, tropical cyclones is a topic which has been given in the NCERT Fundamentals, Class 11th, Fundamental of Physical Geography, the book for Class 11th. And in that, in Chapter 10, you have the atmospheric circulation and weather systems. It is in this chapter where the book has dealt with the aspect of pressure systems, pressure belts, eventually also talking about the air masses, temperate cyclones and tropical cyclones. Now in the whole of the chapter, if you take a look at which are the topics from where UPSC necessarily asks you questions about, you will find that the questions are largely based around the tropical cyclones. So let us understand what these tropical cyclones are. But before that, when you hear about the term cyclone, what does a cyclone refer to, or what does a cyclone mean? Cyclone basically ends up meaning a circular motion which is provided in the winds and that causes stormy weather conditions in an area. Now, these cyclones are nothing but intense low pressure systems, very, very intense low pressure systems. Now, when you have that low pressure system in a particular area, it will attract winds from all different directions. Why? Because of the basic fundamental that winds always blow from a high pressure to a low pressure. So low pressure becomes the attractor of the winds. Now, if this kind of a system or such a system exists in temperate regions beyond the tropics, that is what we refer to as the temperate cyclones. Now there, the formation of temperate cyclones is completely different. The formation of a temperate cyclone, the existence and the property of a temperate cyclone is very different from that of a tropical cyclone. But why we focus more on tropical cyclone is that India is impacted by the tropical cyclone. Temperate cyclones rarely have any influence on us, and that is what UPSC also utilizes. Basically, any question of UPSC has got to deal with the problems and the issues faced by India. Because tropical cyclones are the ones which confront us, that is why you will find questions associated with that as well. Now, having said that, when we talk about this low pressure system, how is it that we achieve a circular motion of the winds? And what is the direction of circulation? Let us understand that. So basically, the direction of circulation created by a cyclonic low pressure is different in the northern hemisphere, is different in the southern hemisphere. What do I mean by that? Let us understand. So let's suppose if you take a look at the broader purview of it. So if you have a low pressure system in any particular region, this will be attracting winds from all directions. And the winds also, after getting heated up, if the reason of the low pressure is thermal low pressure or low pressure created due to heating, now these winds will also get heated up and they will then start rising up in a spiral manner. So you will basically end up achieving a rising column of air, a rising spiral of air. So this is where the winds actually end up rising. But here you observe a kind of a circular motion. Now that circular motion is induced because of the Coriolis force. What is a Coriolis force? The apparent force induced by the wind movement, on the oceanic circulation, etc., when you have the impact due to the rotation of the planet. As the planet rotates, due to that effect, you have the winds moving in the northern hemisphere, they bend to their right, and the winds moving in the southern hemisphere, they bend to their left. So when we talk about the northern hemisphere, let us take a look at the circulation created. In the northern hemisphere, if you have a low pressure center, the winds will be attracted from all directions. And we do know that due to Coriolis effect, the winds will get diverted and will bend to the right. So the winds, they bend to the right here. So if let's suppose you stand at the center of the low pressure and you are asked about what is the direction of the wind circulation, what will you report? You will basically say that around the low pressure, the wind movement is somewhat like this. The winds won't be able to reach the center of the low pressure owing to the bending. Now, what is the direction of this circulation? This is basically an anti-clockwise circulation. Anti-clockwise circulation. Okay. Then, when we talk about the southern hemisphere, this actually undergoes a reversal. So, in the southern hemisphere, if you consider that low pressure center, this will again attract winds from all directions. Again will attract winds from all directions. Now here, the winds will bend to the left owing to the Coriolis effect. So here, the winds will bend like this. So again, if we follow the similar exercise, if we ask you to stand at the center of the low pressure and report the direction of the wind movement, what will be the direction? The direction of the wind movement will be somewhat like this. And what is this direction? This is clockwise circulation. Clockwise circulation. So that is how, when we talk about cyclonic circulation in the northern hemisphere, the direction of the wind movement is anti-clockwise, and the cyclonic circulation in the southern hemisphere, direction of wind movement is basically clockwise. Ideally, you should not rote learn this. You should apply your logic, draw it in a piece of paper so that it is retained for a longer duration. If you ratify it, there are increased chances that you will forget it or will get confused in the concept come the time of the examination. So always apply the logic and try to draw it on the paper on your own. Just you have to apply the basic principle of Coriolis force. The bending is to the right in the northern hemisphere, bending is to the left in the southern hemisphere. This is the chart. So cyclonic system, low pressure center. The northern hemisphere you have anti-clockwise circulation. In the southern hemisphere you achieve a clockwise circulation. Now, after that, when we talk about a tropical cyclone, where does it exist and what are its properties? So tropical cyclone, as the name in itself suggests, extends and exists in the tropical regions of the world. By tropical regions, we basically mean roughly from around 5 degree to 30 degree in the northern hemisphere and 5 degree to 30 degree in the southern hemisphere. This is where you have the generation and the creation of a tropical cyclone. Now, why in these areas? And what is it that leads to the formation of these cyclones? So, you have a low pressure which is created due to intense heating by the sun. Now, that intense heating by the sun increases the temperature of the water bodies, that is the seas and the oceans of that area. Now, once those water bodies, they start getting heated up at a temperature around 28, 29, sometimes 30, 32 degrees Celsius, that intense low pressure attracts winds from all directions and you have a circular motion which is achieved. And that circular motion induces the occurrence of a cyclone. So here, these kind of impacts are observed not only in the region of Bay of Bengal and Arabian Sea, but these kind of impacts are observed in tropical waters across the world, wherever water can get acutely heated up and create that low pressure center. But then the phenomena is known differently in different parts of the world. For example, when such disturbances occur in the region of northern Indian Ocean, be it Arabian Sea or Bay of Bengal, we refer to them as cyclones itself. But when you have such occurrences in the region of Atlantic and in the region of Eastern Pacific, that is the US coastline, there it is known as hurricanes. Then if such occurrences, they do occur in the region of South China Sea, then or in the Western Pacific, that is when we refer to it as typhoons. And if such occurrences, they are observed in the region of Western and Northern Australia, they are known as willy willies. So that is how the naming is different, but the phenomena is the same. As you can observe here, that here it is known as typhoons in this region, hurricanes in this area, willy willies, and in the region of northern Indian Ocean, be it Arabian Sea or Bay of Bengal, it is known as cyclones. Now, any low pressure system anywhere due to intense heating, can it generate a cyclone? Land also gets heated up. On the land areas, you experience temperature during the summer months close to around 40 degrees Celsius. Will that generate a cyclone? Equator is the one which gets heated up more supremely throughout the year. So, will the equator generate a cyclone? So, will any kind of heating generate a cyclone? No. You need certain prerequisite conditions to be met. Only then you will have a cyclonic circulation to be in existence. Otherwise, you will have those low pressure centers. It can cause rains, but a cyclonic formation won't occur. So what are the conditions required for the formation of a tropical cyclone? Let us take a look at that. So these are the 4 basic criteria which must be met. First is large sea surface with temperature higher than 27 degrees Celsius. This is a prerequisite condition. It cannot form over land areas. Why? We'll take a look at it. It will be formed only over large water bodies where the temperature is higher than 27 degrees Celsius. Only then will you have the creation of intense low pressure. That will be able to attract winds. Then Coriolis force is a must, because it is the impact of the Coriolis force due to which the winds will achieve a circulation or a circular motion. If Coriolis force does not exist, the winds will come there, rise up, cause rainfall, and the low pressure will get dissipated. If we have to observe that circular motion and rising air, for that Coriolis force is a must. At equator, Coriolis force is 0. That is why this Coriolis force is the reason why you don't have any cyclonic formations at equator, neither will you observe any cyclone to be crossing the region of equator. Hence, no cyclonic formation at equator. Formation at equator. Then, small variation in the vertical wind speed, what is also known as wind shear. What does that mean? It basically tells you that when you have wind movement at the surface and at an upper elevation, let's suppose we consider this velocity of wind at the surface as Vs and here velocity as V1. Now this V1 and Vs needs to be similar. Why? Because let's suppose V1 is very, very high. The wind at an upper atmosphere, let's suppose, is moving at 300 km per hour. Just an assumption. And here it is moving at 30 km per hour. What will happen? Let's suppose that rising air ends up creating a cloud format or a band of cloud. Now those clouds will easily be blown away by the wind, will be dispersed by the wind because the upper elevation wind is very fast and the entire circulation won't be able to develop. That is why you basically need V1 and Vs to be almost similar. Difference in the wind speed at different levels should not be very high. Then other than that, a pre-existing weak low pressure area over the water body, that creates a condition where that low pressure can automatically get intensified. So this is also very important, a pre-existing weak low pressure area. Now, these are the conditions required. Let us now try to understand the formation of tropical cyclone and the various different stages involved in the process of formation. So when we talk about the formation here, this will always occur over very large water bodies, that is seas and the oceans of the world. So here, let's assume a large water body. Now here, when you take a large water body, let's suppose this gets heated up quite significantly. So if you have a low pressure region here, now here you might have a doubt that why is it that only this area will get heated up, why not the entire water body? So think about it. Wherever you live, do you experience the same temperature as your neighboring district? No. There is differential rate of heating and cooling experienced in different areas owing to the wind movement, owing to the cloud cover, owing to the factors associated with evaporation, convection of air, etc. So as a consequence of that, large patches of water bodies, they end up gaining heat substantially sometimes and sometimes tend to remain slightly cooler. Sometimes when you have that intense low pressure due to thermal heating, then what happens? A low pressure is created. Now this low pressure will attract winds from all directions. It will basically end up attracting winds from all directions. Now these winds, they will have a characteristic. That is, they will be warm, but they will be very moist, heavily laden with water vapor. Why? Because these are coming from marine regions, from over water bodies. So the moisture content will be very, very high. Now, as these winds come here, they will also get heated up. Heated air is lighter, always tends to rise up. So this heated air will start to rise up. This heated air will start to rise up. As the air rises up, immediately it will reach saturation. It will cool down beyond that and will undergo condensation. So here there will be condensation. And clouds will be formed. So if you think about it, where will the clouds get created? The winds, they rise in a circular manner, right? As the winds rise in a circular manner, the cloud formation will always be around that spiral. It is not as if the winds are rising like this, the cloud will be created here. It will always basically be in the pathway of the wind movement. That is what is cooling down. That is what is undergoing condensation. So here, as the winds rise up, they will cool down and they will create that condensation. So there will be condensation leading to the formation of dense clouds here, cumulonimbus clouds. Now these clouds will be formed all around the sides where the wind is rising up because of the path of the winds. Now, another important concept comes here, and that is the concept of latent heat of condensation. Now, whenever there is condensation, that is the change of state from vapor to liquid or sometimes vapor to solid, there is that change of state, and during that change of state, heat is released. So that is the latent heat. So here basically you have latent heat of condensation which is released. So due to this, all the latent heat of condensation will be released. So release of latent heat of condensation. Heat of condensation. Now that latent heat of condensation, what will it do? It will significantly increase the temperature in the central portion of the cyclone. Now when the temperature in the central portion will increase, means what? It means that you will not have any condensation in the central portion. The central portion will be free of any cloud cover, because for formation of cloud, you need condensation. For condensation, you need cooling impact. But here, the temperature is higher. So basically, you will have no cloud formation here. That is why the cyclones give you an appearance that you see here. In the image that we had seen, here you observe the cyclone, observe the central portion. It is free of the cloud cover. This central portion is what we refer to as the eye of the cyclone. Every tropical cyclone will develop an eye. All the tropical cyclones will have a significant eye which is developed. So that is free of any cloud cover. So here you have the eye of the cyclone. Eye. And on the sides, this is known as eye wall, where you have very dense cloud cover which is in existence. Now after some time, what happens? Because of the dynamic upward rise of the air, you have a suction created in the center. So you have sinking air in the center, in the eye, sinking air. And why is that sinking air created? That is created because of the fluidic motion of air in the upward spiral creates that suction force in the central portion. Now this will end up carrying that heat and providing that heat to the low pressure region. So what will happen? The low pressure will get further heated up. As the low pressure gets heated up means more winds will be attracted. These are moist winds. So more winds get attracted means more winds will rise up, more condensation will happen, and the cycle basically continues. That is why as long as the cyclone is above water, you have the self-sustenance of the cyclone and the strengthening and intensification of cyclone which is observed. And here you will observe that it is the latent heat of condensation by this cyclone which ensures that it is able to sustain the low pressure, make its low pressure even stronger. That is an important factor due to which this cyclone is also what is referred to as a heat engine. Heat engine. And why is that the case? That is because, simple flow chart here, low pressure attracts winds, Now these winds will undergo condensation because they are moist. They undergo condensation. As they undergo condensation means what? There will be latent heat which will be released. Latent heat is released. As the latent heat is released means what? Intensification of low pressure. And that intensification of low pressure will attract more winds, and you have this self-sustaining and intensification cycle which continues. That is the reason why low pressure over the land areas, they are not able to generate a cyclone, because there the winds over the land area will be drier. They will never have that amount of moisture. That latent heat of condensation becomes an important factor. Now, this is the entire cyclonic circulation. Now, when you observe this cyclonic circulation, it ends up moving from one region to another under the influence of the permanent wind system, and in the tropics, the permanent winds are trade winds. The direction of the trade winds is always east to west. So that is why the general movement of these cyclones will be east to west. Now, this circulation, let's suppose it encounters a land area. What will happen? You will experience very strong wind movement till the eye comes over. When the eye comes over, calm condition, clear sky, because no clouds above the eye. And again followed by another tail of that cyclone, which again causes devastation and significant destruction. But when the cyclone hits the land, that is the event which we refer to as landfall. And when you have the landfall happening, that is when the moisture supply gets cut off. And that is when the cyclone starts weakening, because no moisture supply means no latent heat of condensation, means no further intensification of the low pressure. Rainfall will cool down that region, and the end of the cyclone is basically achieved. But whenever you have this tropical cyclone, immediately you experience coastal flooding, which is very prominent. Why do you experience that coastal flooding? That is because of an impact or an effect that we refer to as a storm surge. Basically, when you have wind movement in the coastal areas, the winds carry significant amount of water in the help of the waves. But when you have stormy conditions like a cyclone, the winds, by their air drag resistance, they are able to carry much more amount of water, and they are able to bring much more amount of water. The powerful winds are able to drag much more amount of water in the inland areas. That is the reason why you experience coastal flooding. So, these cyclones, they are very devastating. They are classified based upon the strength of the winds. When the wind speeds increase to over 220 km per hour, that is when we refer to it as super cyclones, having the maximum potential for disaster. So that is all that you need to know when it comes to tropical cyclones. So in this video, what is it that we have looked at? What is a cyclone? What is a cyclonic circulation? What are the different types of circulation which are achieved in the northern and the southern hemisphere? What is a tropical cyclone? How it is created? Why it is referred to as a heat engine? The relevance of the latent heat of condensation? The prerequisite conditions for the generation and sustenance of a tropical cyclone? What is their direction of movement? And when does the cyclone end? It is from this area where UPSC has been repeating questions. So do revise this and do try to formulate your own diagram, and that is something sufficient for the exam. If you have liked the session, if you have liked the content, please put that in the comment section, and don't forget to click on the like, share and the subscribe button. Till we meet again, take care of yourself. Goodbye. Thank you.
NCERT books are unavoidable to crack the IAS exam. Not only is the content of these books authentic, but these books also help a civil services aspirant to build conceptual clarity. And most importantly, lots of questions in the civil services examination are directly asked from NCERT books. But the aspirants often find it difficult to cover these books, or worse, they even end up ignoring these books. We at Unacademy IAS English are going to make the reading and understanding of the NCERT books easier. We present NCERT Fundamentals course, a free initiative of Unacademy IAS English. What are the highlights of this program? Comprehensive coverage of the most relevant NCERT books for the civil services exam. Prelims and mains practice questions in each session to test your understanding of the fundamental concepts. This course begins from 12th of July every day at 6 p.m. right here on our YouTube channel. Subscribe to the channel now.